and take it from here. And I will be here to help you.
Great. You can take the stage here.
Good morning, everybody. Thanks for being here on a pretty hard day to get to Broadway. So I'm Brian Brown. I was on the schedule here. I'm with Low Voltage Contractors. We are a fire alarm vendor, obviously, low voltage systems, gas protection, security, mass paging, voice data, etc. We have a CAD department. I've been with the company for 13 years. As in the service department, so I've worked with end users, engineers to negotiate service contracts. You know, Delta, Boston Scientific, where you guys are going to visit. I know Quebec. I've personally been working with him for years. My career path is when I got out of college, I was an English major. I managed Kinko's for a few years. I was director of operations at the Minnesota Children's Museum, and we had to switch fire alarm vendors, and Low Voltage Contractors was the company that came through for us in a pinch, and I've been working for them for 13 years. I'm new in this current role. I've been in the systems division, so what I'm doing now, just the first year really officially, is working with going from end users, engineers, building managers now to general contractors, electrical contractors, to work on new construction, remodels, retrofits, renovations, etc. So I'm here as more of a student. I'd like to introduce my mentor at Low Voltage Contractors. John Fabian is one of the premier experts in the state of Minnesota on this system. So I look forward to learning from him just as much as he does.
Good morning. Good morning, guys. Again, John Fabian, I'm the sales manager. Well, recently I've had a little bit of a change in my title, shall we say. Now I'm the director of business development for Low Voltage Contractors. What does that mean? I'm a sales guy. So, but I've been in the industry, I hate to say this, none of you were born, since my father actually owned a Muzak franchise in Fargo, North Dakota. I don't know if you guys are even familiar with Muzak, but it's background music, paging systems, and intercom, banks, and medical offices, and grocery stores, and all that kind of stuff. And I started installing speakers and acoustical tile ceilings at about the age of 15, pulling cable all over the place, and did that for, until I graduated from college, and then my dad said, get out there and find a real job, and so I did. And I've been in the fire alarm business since 1981. Started with a company known as Simplex. Some of you may or may not know that name, but that was a scenario that lasted for about a year, and then I was still young enough and footloose and fancy free enough, I decided to pick up and move to Colorado, and started with a company out there known as Pyrotronics in 1983, and been doing really fire alarm, security, paging systems, and gas detection, and all of the above, shall we say, ever since. And, it's a great industry. There's certainly an opportunity to make some money, and it's a fun lifestyle. There's opportunities in our industry that I don't know if you want me to spend much time on this, but at least give you a little bit of a flavor of what we do. We sell and install low voltage systems predominantly in commercial buildings. We don't get very involved in the residential market at all. That would be the single family home market. We do residential, of course, in multi-tenant type buildings, whether it be apartments or condos. This project is going to be coming out of the ground soon up in Minneapolis called Ford Marquette. And we're looking at about a 28-story facility there. It's all rental housing. So pretty cool stuff. So with selling and installing, that also means that we need to maintain. And well, first of all, engineer systems, get them installed, and then we need to maintain them. We started this company, not me personally, but I've been with LVC for about 9 years now. But the company actually started in 1982 with 4 people. We have 87 people on staff now, including all, install, service, administrative people, sales people, management, so on and so forth. So with that said, there's opportunities at LBC from engineering and drafting to sales to service technician to administrative duties and so on and so forth. And we're growing. We are always on the lookout for good people. With that said, let's jump into our project. Let's talk about the paging system first. It's pretty straightforward, pretty simple. Do you guys have a reflected ceiling plan associated with this project?
Mm-hmm.
Okay. Can you give me some idea of what that looks like?
Give me 1 second here. Let's go to the first floor, low voltage, very well. There is our reflective ceiling. I don't know if you can see it.
Okay.
Good enough. There you go.
So it looks like
2 by 2.
you've got acoustical ceiling 2 foot by 2 foot,
Yeah.
pretty much everywhere on the first floor with the exception of the manufacturing area,
Yep.
right?
Yeah.
Okay. All of you have seen the round paging speakers, I assume, that are installed inside acoustical ceiling tile. They're pretty much the industry standard. Some things to know about those speakers. Wherever you're dealing with a standard ceiling height, let's say from 8.5 to 10, 12 feet, whatever the case is.
This is 9 foot. All of them are 9.
All 9 foot?
Yeah.
Okay. At 9 foot, an 8-inch round speaker installed in acoustical ceiling will give you about 400 square feet of coverage. And if the square root of 400, of course, is 20. So 20 foot by 20 foot. As you're applying these speakers in the design, shall we say, what you would really want to be looking at is, this is an ACT area here, I presume, is you would come in 10 feet from one wall, 10 feet from the other wall,
That's okay. That's
and place your first speaker. All right? So from there, you can go 20 feet and 20 feet on axis. Okay? And go ahead and fill in your design on 20-foot centers until you've filled out the space. Now, of course, you're going to have some nooks and crannies and things like that that aren't necessarily going to be the perfect fit. So you got to use a little bit of judgment in terms of your design, and make sure that at least you're overlapping as opposed to extending beyond 20 feet to the next speaker. Make sense? All right. When we get into the manufacturing area, that's a high ceiling. It's open. I don't know what there is for structure out in the middle, if there's columns or not. There may be.
There's no columns. There is a lot of machines.
A lot of machines.
Up to a height, and there is a catwalk that can go. The ceiling here is 21 feet
Okay.
from the floor, and the equipment goes up to 9 foot.
9 foot.
And there's a catwalk at the top of them. So
Is the equipment pretty loud? Is there a high ambient noise
Yes.
level in that area? Okay. Any idea what the decibel level might be as the equipment is running? Shall we just say it's 85 decibels in there?
that's about right.
Okay, that's pretty loud. Hearing protection is required in that scenario. So as far as voice paging is concerned, the re-entrant horn type speaker would probably be the one that you would want to choose.
That's the one that's specified to
Okay.
the speaker.
Okay,
So,
very good. The re-entrant horn type speaker you can get in several different configurations or types, and we'll get back to some of the electrical characteristics here. I just want to kind of talk about acoustics to begin with, as far as where to place these devices and so on. Again, this can be done at your discretion, but the one thing you want to do is you want to take a look at if you can find some information out there relative to re-entrant type horn speakers. A great resource is a company called Atlas Sound, ATLAS. You may want to write that down and search their website sometime here in the near future. Another one is QUAM, QUAM. Both of these companies are kind of industry standard manufacturers in paging speakers. Not only the 8-inch round, type that you install in ceiling tile, but also the reentry horn type speakers. Okay. You'll be able to find data on their websites that will indicate to you what their angle of dispersion is, as well as what their decibel ratings are at various wattage caps. Okay. So now we're going to talk a little bit of electrical. These paging systems operate on an AC electrical current. Nominally, you're looking at a 70-volt line from your amplifier to the speakers. There's another voltage that's used commonly, 25-volt line. Okay. I recommend 70 volts. Especially if you're looking at some longer cable runs, why would you want to use 70 volts as opposed to 25 volts?
Higher voltage and less current.
Correct. Less voltage.
Yeah.
Okay. So I always recommend using 70 volt line. So let's get back to the speaker. Okay, the reentry horn type speaker. You're going to be looking at a scenario where you're going to want to understand what that speaker's angle of dispersion is, or sound dispersion. It is conical, okay? You will mount these speakers on the walls, and then you're going to have some idea of what their decibel output is at 10 feet on axis, okay? And that's kind of what you want to look at in terms of placement of these devices. And then what wattage tap. And again, I don't have any of this memorized by any means, but typically you're going to see a situation where a 30-watt horn type speaker, that's its total capability of delivering 30 watts. Let's say it's tapped at 5 watts. It can give you, let's say, 80 decibels at 10 feet on axis. Now, as you increase your distance away from that speaker, for every 10 feet, your sound pressure level reduces by 1/2. Okay? So, with that said, sound pressure level doesn't necessarily relate directly to decibel level, but what you want to try to achieve is to get you in a situation where when you're out in the middle of this room and your assumption is that you've got an 80 decibel ambient noise level, you want that sound to be approximately 15 decibels above the ambient noise level for it to be heard. Okay. Due to the nature of the construction of this area, I assume that it's very bouncy. Yeah.
Is that, when you said above the ambient noise level, is that pretty much standard for all rooms and stuff? Or just-
No, in the office areas, you're probably looking at more like 50 to 55 decibels ambient noise. This room here, if you just listen, you hear some kind of equipment device, you hear very low noise in here. This is about 50 to 55 dB if you turn on the decibel meter. Anybody got a dB meter on their cell phone? I haven't downloaded my new app because it just got a good cell phone. I gotta do that yet. But typically you're looking at about 50 to 55 decibels, like in an open office area or private offices, conference rooms, that kind of thing. That is what the ear handling units and other systems in the building, when they're just running at their normal operation, that's the kind of sound level that you're going to have. If you've got loud machinery out in this area, you have to compensate for that higher dB in your paging system. Okay. So take a look at angle of dispersion and what is your decibel level at X feet at various wattage taps. And then you're going to have to determine in order to achieve 15 decibels above ambient, what do you have to do as far as speaker placement, quantity of speakers, in order to achieve that out in the middle of that space? Okay. Any questions? Does that make sense?
You said noise protection would be required in there? Or like
Very
ear
possible.
protection?
Yeah.
Do you have to make it stronger then? Or louder?
Well, you know, again, that's something that's going to have to come into play as far as if hearing protection is required. A paging system really doesn't do a whole lot of good, does it? You know, I mean, from a practical perspective. But for the sake of this project, maybe we ought to assume something less. You know, but typically, from my experience, when I'm dealing with manufacturing facilities of pretty much any type, where there is machinery and equipment that's running, your decibel level is usually up around 80 dB. Okay, so when you turn in your project, tell your instructor what your assumptions are going in on it, so that you can make it work. Does that make sense? So the reentrant horn type speakers are the way to go in there. It would really be nice if there was a way. Well, let's look at one other thing. Any idea what the ceiling construction is in this area? Is it open?
Open all the way to
Noise.
21. Structure.
Okay, you could even possibly look at mounting these devices up in the joists in the structure and the ceiling as well. Not necessarily having to be on the walls. Yeah, I would put speakers on the perimeter walls, but then maybe you strategically locate some of these speakers in the joists, pointing downward.
Just kind of a little bit of,
You sure could. Again, you don't know what the actual processes are that are in there.
This is 80 feet by, almost 80 feet by 80 feet area, so.
Okay. So you would be looking at, at least on the perimeter, at 80 feet, you're probably looking at 3 or 4 horns along the exterior walls on each wall section, and then possibly supplementing with some in the middle, within the space itself on the ceiling. Okay. The paging system can be zoned, and you may want to take a look at that. I don't know that there was any criteria, was there, as far as zoning? It does talk about provide an interface for telephone tie-in. Virtually all commercial TVX phone systems have a paging feature where you dial a couple of digits on the keypad, it opens the top half, and it sends a line level or low level audio signal out from the phone system exchange to a paging system amplifier. Okay. That low level audio signal that is translated in the amplifier and then dispersed out to the speakers. If you do paging and zone your paging, take a look at what the logical zones would be. Offices, maybe main office area is one zone, manufacturing is another zone, upper level could be a third zone. And then you do that simply by providing an amplifier, dedicated amplifier for each area, and then you have to do some switching. And that switching is done through, generally, in the case of telephone paging, it's done in the phone system. You just dial the code for which paging zone it is you want to send a page to, and then you'll have individual outputs for those zones. Plus, you can do a combination of zones and or all. Okay. Everybody with me? All right. As far as amplifiers are concerned, you'll want to set up your amplification application, with a couple of different things in mind. Number one, you gotta have a preamplifier that processes your inputs to the speaker system, or to the audio system. The preamplifier is simply something that you can adjust the gain on your inputs. One would be your telephone paging input. You may want to use a microphone at the reception desk, where you can just key the mic and say, Joe, you have a call holding on line 3, or whatever the case is. So that would be another input into your preamplifier. The preamplifier then processes these audio inputs and sends them to the power amplifier. Okay. Power amplifier is actually what delivers your 70 volts out to the speakers. Another thing that you can keep in mind is that you don't necessarily have to provide a separate preamplifier and a separate power amplifier. There are also what we call integrated amplifiers out there that provide you with your inputs and your power to drive the speakers all in one group. Okay. Some manufacturer names that you may want to look at in terms of selection of this equipment would be Bogen, B-O-G-E-N. Another good one that we use frequently is TOA, T-O-A, TOA Electronics. Those are pretty much the two standard paging system manufacturers that you see out there in the world. There's hundreds of them, but those are the two most common names and probably the two most widely used. They have an array of products that fit what you're looking at doing here beautifully. Sizing your amplifier, sizing your power amplifier. I mentioned that if you're going to zone the system, you're going to need a separate power amplifier for each zone. And the reason for that is that the output off that amplifier, although it can be split, it makes a lot more sense not to do that. And just dedicate the output off of that power amplifier to the zone of speakers that is connected to it. So if that be the case, you would need multiple power amplifiers. As far as sizing is concerned, you need to do some math in terms of the wattage cap that your speakers are set at. That would be the maximum number of watts that they would draw while you're in service, okay, or while they're active. Typically, an 8-inch round ceiling speaker that's installed in an ACT, you would set at 1 watt. And that 1 watt will probably give you about 75 to 80 decibels output. Maybe way more than what you need. You might find yourself, because you're in a very quiet atmosphere, like for example in this room, you would probably have what, 2 speakers in here. You tap them at a 1/4 watt, and 1/4 of a watt, and have perfectly good decibels. The other thing that you want to keep in mind when you're looking at a paging system is intelligibility. It's going to be very difficult to achieve intelligibility in this area here, just because you have a high ambient noise level, you got a lot of bounce and echo and all that kind of stuff based on the structure of the room. In here you have some soft, and it's a quiet room because ACT absorbs sound. And as a result, your acoustics are much better for intelligibility than they are in a hard wall and hard ceiling type room with extra equipment and all that kind of stuff running at a high decibel level. You have so much bounce that intelligibility becomes very difficult to achieve. What is intelligibility? It's the ability to be able to understand what is being said on the speakers. As such, your better off designing to have more speakers and a lower wattage setting than you would to design fewer speakers at a higher wattage setting. Two reasons for that. The closer you are to a speaker, or proximity, the closer your proximity is to a speaker, the better you're going to be able to understand what's coming out of that speaker. Number two, the higher you drive a speaker in terms of its output. Let's say a 30-watt horn, Mansion horn type speaker that's capped at 30 watts is probably putting out somewhere close to 100 decibels, and intelligibility becomes difficult because you're overdriving that speaker to the sense that it's not performing at its optimum signal to noise ratio. And signal to noise is simply where the more signal you put into it, the greater the power, the more the noise becomes that's created in its performance. And that noise translates to not being able to understand the consonants as well, things like that. You hear, so more speakers, less wattage is the key to intelligibility. That's about all I got to say about paging systems. Anybody? Questions? Brian?
Sorry. I'll sit you at the office for a couple.
Yeah, I'm sure you will.
All right, so that's good. So we've taken care of that. Did you want me to talk about security?
Yeah, that'll be
I
nice.
mean, I'm not a security expert, but is it in the?
It's up right there.
Yeah, okay, you got a main security panel, you got door contacts, exterior doors, motion detectors for corridors, glass break sensors, and exterior perimeter windows, audible alarm, main staff keypad at main entrance here.
And the security, they have done it for the commercial project. It's really no different than what we have done in the commercial project. So
It is,
they're
that's,
familiar with it.
that's really all it is.
Yeah.
If you've already done it, you probably have a.
Yeah,
a
if there's an
pretty good
exterior
handle on
door, they stick door contact. If there's a wall that has multiple windows, right in the middle of the wall, you put the glass break that sends all the break in all the windows in that wall, and
it. Yep,
so that's what we've done in the past.
yep,
So,
okay. Then,
do you guys feel comfortable with that one? Because we've done the security system. The right here is very, very similar to the commercial project. So we have a keypad that we have to put on the main entrance.
yep,
So that's
that's where you arm and disarm.
yeah,
the
arm and
system.
disarm the system, and a couple of exterior wall doors over here.
Doors,
Yeah.
yep.
And what's not?
Those good contacts.
Yep.
Um,
So that's what we basically done
mhm,
with these. So
okay.
let me see eraser. Where's my eraser here? Oops, doesn't want to erase. There you go.
There you go.
Yeah. So that's a couple of things.
The panel itself needs to be connected to phone line or radio or cell phone, or what else can you transmit on? IP? Why? What good does the security system do if you're not connected to an outside source? Nothing. It's their, what is it called, the cops. Whether you've heard this or understand this or not, I'll mention it. Any security system needs to be monitored at a 24-hour central station. That security system signal comes in, they pick up the phone, and they call the police department. So we have an intrusion at this building, which you asked them. So, security, this type of protection is typically known as burglar alarm. There's no access control, there's no video, there's none of that. It's simply protecting the perimeter of the facility door contacts. And then you also have some interior protection via the motion sensors. Motion sensors you would select based on, again, angle of dispersion and the distance out away from the device that you can pick up motion. Standard technology, motion sensors is known as passive infrared. Everybody's looking for body moving with motion. Glass break sensors, generally they operate on ultrasonic technology, which they're basically a microphone that's listening to the frequency level of breaking glass. And when that glass breaks, it sends an alarm. Pretty simple stuff. Going on for years and years and years. How'd you know that? Right. Okay, let's get into the fun stuff now. Fire alarm. Does anybody know what the occupancy classification for this building is? Have you been given that information?
Industrial, commercial.
Okay. This is the Minnesota State Fire Code. This is an adoption of the International Fire Code, the 2006 version. And of course, the way things work, you know, government, legislatures, things like that. The 2006 version, just bear with me. The 2006 version of the International Fire Code was finally adopted by the state of Minnesota in 2007. Therefore, it says 2007 Minnesota State Fire Code. Also, the state of Minnesota amended the 2006 International Fire Code to kind of customize it to the state of Minnesota. Don't ask me why. It's bureaucracy. Anything and everything that you need to know about where a fire alarm system is required is found in Chapter 907 of the Minnesota State Fire Code. And 97 is titled Fire Alarm and Detection Systems. Okay. Now we're going to, at some point here in the next year, probably be adopting a new code, but as of today, the 2007 Minnesota State Fire Code is your Bible, right? Now, just based on what's going on in this building, we have what we would call a mixed-use occupancy in this building. And you can find these occupancy definitions in the front part of the code under the administration chapter, or the paragraphs labeled definitions. And under definitions, you have what's called occupancy classification. And it goes through all the various groups or types of occupancy classifications that buildings are classified into. Okay. You have business groups, you have education groups, education being K through 12 educational programs. Strictly that. This building here is not a K through 12 educational facility. Therefore, it's a B occupancy or business occupancy. Okay. So it's a pretty wide and encompassing classification as far as business. Certainly, a portion of this building is B occupancy or business occupancy. Okay. What would this area be? It's not, I can't ask you that question because you can't tell me. I'll just tell you that it is industrial group F for factory. Okay. And so with that said, you've actually got two occupancy types in one building, therefore it's called a mixed use occupancy building, class building. That would be class B, class F. Okay. Now, when you read the code, I'm gonna throw you a curveball. Code says that a fire alarm system is, if it's fully sprinkled, and we assume that this building is fully sprinkled, it does not require a fire alarm system for either occupants. Now, what do we do? You know, for the sake of the project, I think any good fire alarm practice would be to provide a fire alarm system, even though it is not required by the code. And you also want to notify the fire department that there is a fire condition in the building. No doubt about that. Okay. So let's go ahead and design a fire alarm system. There's some pretty basic things that you do need to provide in this design that are a function of things that exist in this project, that exist in this building. One, you've got an elevator, right? Okay. The elevator code requires that if that elevator, well, it doesn't matter, if there's 2 or more stops in that elevator, it must have what's called recall. And recall, elevator recall is something, the definition basically is if you have a fire alarm, let's say on the 2nd floor, that elevator must automatically recall to the 1st floor and stop. Okay. If you have a fire alarm on the 1st floor, that elevator must automatically recall to the 2nd floor and stop. So that's primary and alternate recall. In multi-story buildings, which you're not dealing with here, more greater than 2 stories, generally what you do is your primary recall floor is 1st floor, and your secondary recall floor is the 2nd floor. Okay. So you have to control the elevator via smoke detection. Smoke detection, of course, is a part of the fire alarm system. Here's your elevator here. Here's your elevator equipment room. Some things that are absolutely have to have. Number one, you gotta have a smoke detector in the elevator lobby. Okay? And why? Because if we get smoke in this elevator lobby, we need to recall the elevator somewhere else. In other words, we can't have that elevator stop on that floor because you don't want somebody that's in the elevator to have the doors open and walk into a fire. Okay? It's pretty simple stuff. So every elevator lobby has to have a smoke detector, and that would be within 21 feet of the elevator door on the ceiling.
Second one. So it would be one on the 1st floor and one on the 2nd
One on the 1st floor, one on the 2nd floor.
Okay.
Next thing that the elevator code requires is that you have to protect the elevator equipment. That being the equipment that runs the elevator. So we go to the elevator equipment room, and in there you must also have a smoke detector. And that smoke detector also initiates the recall function of the elevator. Okay, how do we recall the elevator? How do we cause the elevator to recall? The elevator equipment itself, the elevator controller, has recall service built into it. The fire alarm system needs to give that elevator equipment a dry contact output. Okay, just a relay. So there would be 2 relays from the fire alarm system that are dedicated to recall service, primary and alternate. Okay. And we'll talk about how all that stuff happens here in a minute. Do we know if the current elevator code does not require sprinkler in the elevator shaft or the elevator pit or the elevator equipment? So I think our assumption should be that we're not sprinkled in those critical elevator areas. Okay. I'll throw a caveat in there. If the elevator shaft and the elevator equipment room are sprinkled, then you must also provide heat detection adjacent to the sprinkler heads that are rated at least 15 degrees less than the feasible leak on the sprinkler head itself. Generally, sprinkler heads are 150 degrees, and standard heat detectors and fire alarm applications are rated for 135 degrees. Isn't that funny why that is? So what happens then if we get heat at 135 degrees? Then the fire alarm system has to provide an output to what's called a shunt trip breaker, which then shuts down the elevator equipment so that it can no longer be used. Okay. In other words, if something is burning inside the shaft or inside the elevator equipment room, you've got to shut everything down. Can't use the elevator. It's just the way it is. But for this, and I only put that out there for information. I wouldn't think that. Let's make the assumption that there is no sprinkler in the elevator equipment or the elevator shaft. Okay. So that's one of the basic things that you have to have in the building, even though a fire alarm system is not required. What else do we have to do in this building from a fire alarm perspective, even though a fire alarm system is not required? We got to monitor the sprinkler system. Right? The sprinkler code requires that any sprinkler system that has 100 heads or more must be monitored off-site by a UL-listed central station, which in turn calls the fire department. So, in your design criteria, it talks about connection to fire protection system devices as follows: 3 tamper switches and 3 flow switches. It also talks about connection to a fire protection horn strobe located above the Siamese connection on the exterior of the building adjacent to mechanical 116. So let's place our first device. Is this mechanical?
Yep, it's
Okay, and it's adjacent to the exterior door. So you would put an exterior horn strobe, which is above the Siamese connection.
anybody here?
Okay, sure. So let's talk about flow switches and tamper switches. Exterior horn strobes for a minute. A sprinkler system has a switch in it called a flow switch. There can be multiple flow switches based on how that sprinkler system is zoned. Okay, in other words, you're providing sprinkler protection to various areas inside a building via what's called sprinkler zones. And I'm not going to get into all that minutia because we can spend a whole day talking about sprinkler design. We're not here to do that. But suffice it to say that a flow switch is something that tells us that we have water flowing in the system. In other words, the sprinkler head is popped, and the water flowing, dumping out on the floor, it's putting out fire. Okay. When there's water flowing in the system, you've got a paddle switch in the pipe. And as that water flows, it causes that paddle switch to move, causing a contact closure, which the fire alarm system is connected to. That contact turns in an alarm, evacuates the building, and calls the fire department. And tamper switches are a supervisory device, essentially, that monitors the position of the valves on the sprinkler system. Anywhere you can turn off the water in the sprinkler system, whether it be at the main entrance or it be on one of, again, the zones or sections of the sprinkler system, there's usually what's called a gate valve. And the gate valve will have a tamper switch on it, so that when that valve is closed, the tamper switch closes and it sends a signal to the fire alarm system. You're required by code to monitor both flow switches and tamper switches. Now, a tamper is not an alarm. It does not evacuate the building. What it does do is it sends a supervisory signal to the control panel. And in turn, sends a supervisory signal to the central station, and basically it says, hey, something is off normal here, you need to go investigate it. Okay? So, there's your sprinkler system. So that's the second thing that a fire alarm system has to do, even though a fire alarm system is not required in this building. Looks like we're going to put one in, doesn't it? The third thing is that you have air handling equipment in this building, and you have a schedule for your.
Yep, it's in the back of the package that I gave you.
Holy cow. We have, you want to know what the sizes are of these air handling units?
Yep, they're in the front.
Voltage, horsepower, tuning, starter size. Do you have anything that just tells us what the CFM ratings are and or tonnage?
No.
Okay, all right.
Let me see, here we go. Fire here. Of course, doesn't want to open it now. Have to move it. Okay, sorry.
No problem.
You want it? Okay.
Well, it's not mandatory. Not mandatory.
You know, it should be. I just have.
But if you've got a mechanical equipment list that tells us what the sizes of these units are, that would be helpful.
Yeah, the only thing that I have is the one that you're looking
Okay,
at.
that's fine. Let's assume.
Yeah.
I'm going to tell you where a fire alarm has to interface with an air handling.
But these are the all handling, and so yeah.
Mhm. So you've got.
The horsepower is right
You got-
here.
Looks like supply and return.
Sublime return, three of them, yeah.
Okay.
We don't have the you know, the
Yeah, the
airflow
horsepower to me
information.
doesn't translate to the capacity of the unit.
Yeah.
You know, so maybe I should Google that. I wonder if there's a correlation. Generally, air handling units are, and even more so rooftop units, which is an air handling unit that sits on the roof, are sized by either CFM capacity, which is cubic feet per minute, air movement that they can push, you know, their maximum air output, or by tonnage. Okay, a 4-ton air handling unit is 2,000 CFM. Excuse me, a 5-ton air handling unit is 2,000 CFM. Okay, 400 CFM per ton. Maybe you want to make a note of that because that'll be useful information for you in the future. Now, the mechanical code, not the fire code, the mechanical code says that all air handling units rated at 2,000 CFM or greater must have smoke detection to shut it down. Okay. We accomplish smoke detection on an air handling unit through a device known as a duct type smoke detector. Or literally it's a smoke detector that's installed on the side of the ductwork. It's got a tube that penetrates across the width of the duct on the inside. And if there's smoke in that airstream inside the duct, that smoke enters that sampling tube, passes that air through the detector itself, which is mounted on the exterior of the duct. And if it reaches, let's say, 3% per foot obscuration, boom, you get a supervisory signal. Duct detectors are not required to evacuate the building. They're simply there to shut the unit down. Why do we shut the unit down? The code wants us to do that so that we avoid spreading smoke in a building through the air handling system. words, you could have a fire on the opposite side of the building, but the air handler, that's, you know, in the air handler that serves this room, and we could be sitting here talking and having class and having a good time, and all of a sudden we got smoke coming out of the diffuser. What the hell's going on? So you want to shut her down. So we can eliminate that potential. So that's the third thing that a fire alarm system has to do in a building that is not required by the fire code. So with that said, let's make an assumption here. The other thing the mechanical code says is that you must put the duct and smoke detectors on the supply side of the unit. They're not required on the return side. Okay. So it appears to me that you have 3 supply fans and you have 3 return fans.
Right there.
So you would have a duct smoke detector within 5 feet of the last bend into this unit, okay, or takeoff on the supply side. So you need 3 duct smoke detectors. These duct detectors are a detection device that are wired into the fire alarm system. Okay, so we've covered kind of those basics. So the operation of a fire alarm system is to monitor fire events and then be monitored off-site by a listed central station, which calls the fire department and or building owner, you know, depending on the type of signal that's being received. Smoke detectors are not required in this building at all by the code. Now, I believe the criteria says what?
We also, there's an addition to that one, we're also asking for a fire alarm protection in the manufacturing floor,
Okay,
in addition to what the code says.
in addition, okay,
In addition to what the code says, the manufacturing floor, and we typically did beam smoke detectors, and
Right.
if you talk a little bit about that one.
sure,
And so that was the first floor. So right in here. And then we do have a data center right in here. So, and we're requiring a pre-action
yeah,
system here
Okay.
with, and then we typically did the below floor and above floor
Okay.
smoke detectors and the criteria.
okay, great.
So I don't know where you want to start.
Well, let's start with manufacturing, and I like the idea since you have high ceiling.
21 foot.
It is difficult to place area type smoke detectors, so photoelectric beam or photo beam smoke detection is a great application for this device in this room. The reason is you got, what did you say,
21 foot.
21 foot high ceiling.
I see.
And you're what, 80 foot by 80 foot almost?
80
as
by
far
80,
as
yeah.
okay, so beam type smoke detectors can be mounted in any height. Okay. The one thing you want to do is not put them so high that it's not going to get, the smoke's not going to get to it. One thing about the characteristics of fire, smoke, is you've got a couple of different types of smoke. You've got hot smoke, you've got cold smoke. Cold smoke is generally fire that's in its incipient stage or smoldering stage, and there's not a lot of heat associated with that smoke. Therefore, that smoke might come up off of that smoldering fire, let's say, until it gets to the point where the air above it is cooler, excuse me, is warmer than the smoke itself. Therefore, it can't go any higher, right? Because smoke is only going to rise as high as it, until it gets to the equal temperature of the air, right? Now, if you have hot smoke may not necessarily be as visible, right? Products of combustion, let's say from a very hot fire, let's say a gas fire or an alcohol fire, very hot smoke, but you can't see it, right? If you burn alcohol in a Bunsen burner, you don't really see any smoke, but there's products of combustion there, and it's very hot. That'll get all the way to the ceiling. So when you're placing a beam smoke detector, you want to kind of go maybe 10, 12 feet off the floor, or at least as high as you can to avoid any obstruction or high as you need to avoid obstruction in that beam path. Okay? A photoelectric beam smoke detector typically consists of, nowadays technology is a transceiver, which is both a transmitter and receiver in one unit. And then on the opposite end would be a reflector. Okay? And it's just simply a mirror or some type of reflective material that's mounted on the opposite wall in line of sight. Okay? So what happens is that beam is sent down, it bounces off the reflector, and it comes back to the receiver portion of the unit. What it's looking for is obscuration. Okay. Smoke obscures light. Therefore, when you get to 3% per foot light obscuration, it goes into alarm. Pretty simple stuff. So I won't bore you with that anymore. About 260 feet is the maximum distance between the transceiver and the reflector. And then 60 feet is the maximum width of the detection cone, shall we say, that a full beam detector can operate. So 60 feet wide by 260 feet long.
If we put one here and reflector here, because these are 80.
Those are 80. So you may have to go 2 and 1.
Okay.
Maybe.
So then that's your line up.
So you would be 30 feet off the wall with your first transceiver, and then you would go 60 feet. Okay. But now you don't have any detection in this area. So you got to put one here too.
So you said the 60 max, that's the area that this will cover, that, right? Like this?
Right.
Okay, so if I have, that'll give me 40 feet on this side and 40. Right, so
No.
because this is all 80, less than 80 even here.
Yeah, but your
Yeah.
length, maximum
Uh-huh.
distance away to the reflector is 260 feet. Okay. Okay, so I'm looking at this now. Let's go on the perpendicular axis. Okay, 60 feet. 30 feet from
This
side, 30 feet to that side.
Got it.
Total of 60 feet.
So you need to.
So you can't be any more than 30 feet from the
Gotcha.
outside wall to
Gotcha.
your first device.
30 feet. Gotcha. Okay. So you're gonna
Now,
end up with.
you can go from this device at 30 feet from the inside wall. You can go 60 feet to the next device.
Okay.
It's just like the speakers.
Gotcha.
10 feet in from that wall, 10 feet in from that wall, you place your first device, then you can go 20 feet, 20 feet, But everything is always measured from the device being the center of the box, and then you can go either direction as far as its every coverage. Okay, so you've got your smoke detection in the manufacturing area now. Let's go to the data center. There's a pre-action sprinkler system being provided in the data center. And there's also a raised floor in the data center. The raised floor is usually installed in the data center so that all the cabling for all your computer equipment runs under the floor. It's a great place for fires to start. It's an awful lot of electrical equipment under there, high voltage, low voltage, you name it, data cabling, it's all there. So with that said, there's usually, you have a very high value of equipment in here. Insurance companies love it when you protect that equipment. The other thing that they don't like is dumping water on this equipment because it destroys it. So therefore, they have what's called a pre-action sprinkler system. Does anybody know what a pre-action system is? Right? No? Okay. Let me give you a quick explanation of that. pre-action sprinkler system is one in which the pipe is empty. There's no water in the pipe. Okay, it starts from a valve assembly, where the water is held back. That pipe leaves the valve assembly and it goes out to the sprinkler heads within the protected area. Let's say that this room here is the data center, and we've got, sprinkler heads on the ceiling in this room, but there's no water in the pipe. And why is that? Well, you got the maintenance guy in here, and he's got a broom handle that's long, and he's carrying it over his shoulder, he's walking along, and pop, he knocks that sprinkler head off. Believe me, it happens. Well, if there was water in the pipe, now you got water flowing, and you're destroying your computer. Okay, you just can't. You don't want to do. You want to avoid that at all costs. All right. So we have an empty sprinkler pipe that we're going to charge with water if we have to have it, if we really, really need it. Okay, that's why it's called pre-action. Pre-action sprinkler systems are driven by smoke detection, okay, or heat detection. But I think in the case of what we're talking about here, it says provide smoke detection in the pre-action system. What you're doing is you're providing smoke detectors, and in this particular case, you're looking at reducing the spacing of your smoke detectors in this area, as opposed to what you would provide for standard spacing, just out of the normal office areas or manufacturing areas or whatever the case is. And the reason for that is that computer rooms usually have a very high air exchange level in them. It's windy in most rooms. And why is it windy in there? It helps keep the equipment cool. As a matter of fact, around the perimeter of the computer room, you'll have what are called crack units, CRCU. And I'm sorry, I can't remember what the acronym stands for. But what they are is they're air conditioners that sit on top of the raised floor. And you may have 3 of them down this wall and 3 of them down that wall. And what they do is they draw air out of the room and shove it and cool it and shove it into the underfloor, into the subfloor. The subfloor is perforated. There's holes drilled in the floor tiles, right? And that air just comes back up through the holes in the floor tiles and recirculates into the room. Boom, goes back down into the crack unit and gets shoved under the floor again. So they're air conditioners. Just like the window air conditioner in your apartment. Only it's used in the computer room, and it's much bigger. And pretty cool stuff. So that unit is going to be causing many air changes per hour inside that room. One of the things that you'll find as a reference in NFPA 72, okay, I mentioned that the fire code tells you where a fire alarm system is required. NFPA 72 tells you how to install a fire alarm system. You can't have only one reference, you gotta have 2. The one of them tells you where you gotta have it. So if you gotta have it, you gotta go to this document, NFPA 72, that tells you how that system should be installed. And it does it in a very extensive manner, as far as the explanation. So NFPA 72 is in there, and there's an appendix, it's got a chart that says that so many air changes per hour reduce your detector spacing by X percentage. Okay, standard stock-type smoke detectors are rated for 900 square foot coverage. Let's say, for the sake of the project, the air changes per hour in this room would require you to space your detectors on 450 square feet. So what's the square root of 450? Anybody got a calculator? Okay, 21.2. So let's say 21 feet is going to be your spacing for your subfloor smoke detectors. For for that matter, it might be your spacing for your detectors on the ceiling as well. Because even though the air fluid's even greater in the subfloor than it is in the room itself, and that's simply a factor of volume, right? There's far less volume in the subfloor, which is the same square footage, but it's only, let's say, 12 inches deep or 18 inches deep. Whereas the room is 9 foot by the same square footage.
What we have done in the past is we did half what the ceiling placement of the smoke detectors.
Okay.
So like 30 by 30, that
So
gives you
15 by
15 by 15, but I don't know if that's what we've done over the years.
That's perfectly fine.
You know,
You know,
kind of a rule of thumb until you get into the details.
Yeah.
You know what I mean?
Yeah, no, that's cool. If you, let's just call it that. Let's go 15.
15 on center.
Yeah, 15 feet on center. So that means 7.5 feet
From the walls.
perimeter walls in, and then 15 feet, 15 feet. So you're gonna put smoke detectors on the ceiling, in the ceiling tile. But you're also gonna put smoke detectors in the subfloor. And let's just call it all 15 feet, 15 foot space. So with that said, in the subfloor, one thing that you should know is that you cannot mount the smoke detector upside down. In other words, facing upward. When you look at a smoke detector on the ceiling, let's pretend that that's a smoke detector. That's pointing downward, right? If it's pointing upward, this, you get dust and debris and stuff falls into the device, which makes it dirty, which causes it to go false alarm. Okay. So it must be mounted either vertically or facing downward. And you have to do that through the use of whatever, electrical box and clamp or whatever. A raised floor in a computer room has a grid, and that grid it sits on pedestals or feet, right? So when you mount your electrical box that the detector is associated to up off the floor as high as you can get it, okay, the hard floor that is, and then you either invert it so that it's pointing downward, or at least it has to be mounted vertically. Okay. So now that, and then also I believe there was a control panel called for.
Yeah, but before we leave, do you apply it to, this is where the UPS area is, would you apply the same rule to the UPS area?
Usually you do not have reaction in the UPS room,
Okay.
but we sure could. I would say in the UPS room that you aren't going to have all that air movement in there. So you could go with your standard 30 foot by 30 foot spaces
Ceiling.
in the ceiling.
Okay.
In the UPS room. Now the other thing that is not asking for, but in UPS rooms are usually full of batteries. And batteries give off a gas. Anybody know what that gas is? Like acid. HCl. If I was designing this building as a consulting engineer, I would also include gas detection in that group as well. Because batteries, if they're going bad, you give off a lot more gas, which can become not only corrosive but also hazardous to human beings. So that's just a side note. So yeah, there's batteries right there. So standard placement of smoke detectors in the UPS room, and then cut your spacing in half in the computer room itself, both for on the ceiling and in the subfloor. The pre-action system also has a control panel, which we refer to as a releasing panel. It's well listed for that service to what we would call charge the solenoid valve on the pre-action valve assembly. The pre-action valve assembly is installed by the sprinkler contractor. And on that valve assembly, there's a solenoid valve, which when you hit it with a voltage from that control panel, that causes that valve to open, thus allowing the ability for water to flow into the pipe that we talked about was empty, right? So, there's another thing that's involved here too, there's an air compressor. The air compressor actually charges that pipe with air and holds that valve shut. Okay, so even though we've released the valve with the solenoid, the air is still holding the valve shut. Now, that's what we call double interlock, or it's an added safety in that reaction system. So now what has to happen is you've got to have a release of air in order for that valve to open and allow water to flow through the pipe. And the only way you get that release of air is for a sprinkler head to pop. Sprinkler head is popped by there's a leak in the head that melts when it gets to 150 degrees. Okay? So, air comes out, here brings the water. The other thing that you would monitor into this panel on the pre-action valve assembly would be any tamper switches and or flow switch. Okay, that's going to deliver the alarm and supervisory signals to the building fire alarm system. The building fire alarm system is going to monitor this panel for alarm control. And it's going to be labeled as such that the building fire alarm system has pre-action system computer room alarm. If you got an alarm on that pre-action system, you better get your ass down there and stop the fire before you dump water all over your equipment. Okay, so that's the pre-action system, that's the computer room. Any questions on that? Anybody? No? Make sense? All right. Ask questions as you're going along. We're a small group. So. Okay, let's get back to the general building fire alarm system. So we've talked about air handling units, we've talked about the elevators, we've talked about the sprinkler system. Now the pre-action system we've talked about. What's left? There really is no area type smoke detection required in this building. So I believe it even said that in the specification, if I'm not mistaken. At least the copy that I have. The building is fully sprinkled, so full smoke detector coverage is not required. If you want smoke detector coverage, it's over and above the requirement of the code. And if you're going to provide smoke detection, you've already got it here in the manufacturing area with the beam detection, right? Now, what you would do is you would just be applying smoke detection in the office areas, corridors, and the other rooms on 30 foot centers. 15 feet from each wall, first device, and 30 foot. Okay.
The horn strokes. And there you go there.
The second part of the fire alarm system is what we call notification devices. That's a notification device from the ceiling right there. That is a horn strobe. It's a combination audible visual device signaling to alert you that there is a fire in the building. Get the heck out. Okay. Everybody knows that. So how do we place audible visual notification devices? I do it basically based on what is the requirement for visual notification, more so than for audible requirements. The code says, well, NFPA 72 says, which is a part of the code, it's adopted by the state fair code. NFPA 72 says that you must achieve 15 decibels above the ambient noise level of the building for audible evacuation signals. Okay. So typically a horn is rated at for 85 decibels. So you're getting pretty good noise out of a fire alarm horn. 85 dB will give you let's say in this office area, which is at 50 to 55 ambient noise level. And I don't know what the square footage is here that we're dealing with, but
Which one do you want?
really the only, laying these out is kind of at your discretion. The only rule that really applies is that in corridors, you must be within 15 feet of the end of each end of the corridor, and then you space your devices beyond that, depending on the length of the corridor.
So 40 feet.
40 feet, so you're gonna have to have two devices in that corridor because you gotta be within 15
15 feet.
either end. Okay. And then if you look at, let's say this office area, typically we ceiling mount these devices. A strobe rated at 100 candela, which is the light intensity of that strobe device, the visual device, has a coverage of 50 feet by 50 feet. If it's on the wall, it's 50 feet out, away from the wall, on axis, and then 25 feet that direction and 25 feet that direction for a total of 50 feet. Okay? What I would do is I'd lay this thing out with my, keeping in mind that we want to visually notify everybody in the building. And if you have one of these templates, this is the tool to use. I don't know if everybody's seen one of these. If you have these, okay. These boxes are great. You just lay them on your 1/8" scale drawing. It'll tell you what candela rating strobe to use based on, you know, the square footage that you're dealing with. Okay. So what I do is I'll come in 25 feet from the wall. What is the distance between this wall and this wall?
Let me just did it.
40
40
feet.
feet. Yeah.
What's the distance this direction?
We're getting from here to here 63.
63. How many more strobes do you need in there?
Yep.
You can put one on this wall because you're less than 25 feet to either end, so to speak, as far as this space is concerned. And it'll go out 50 feet. Put one on this wall, you're certainly falling within that 25 foot on either side. And you're going to have visual and audio coverage in that room. That'll meet the intent of the
So
house.
50 feet on center for four strobes.
Yeah.
Okay.
That's if you're using 110 strobes.
Okay.
Okay. If you're using a 30 candela strobe, that's basically just 30 foot by 30 foot. Okay, so this template says right on here, your candela ratings and your spacing requirements. And then you can. So,
What I'm always confused is, could I have one here and went all the way to the largest candela guy that can give me 55 by 55, and I cover, most likely you cover the whole area. I mean, if you go 55 by 55 versus going, so what's the kind of the
so the letter of the code, yes,
Yeah,
but in practical terms, no.
okay.
And the reason I say that is because you have obstructions, you want to make sure that your audibility is good. In an office area, you probably have no problem getting away with that. Okay, but if you're in some other kind of process area,
You might have to, yeah.
where the noise level is higher or whatever, you've got equipment, machinery, you have construction, to be able to have line of sight to that strobe, to be able to see it. You know, there's all kinds of factors that come into play. Here you've got, this is cube farm, right? These aren't individual offices with walls that go to the ceiling. So on a cube farm, I would ceiling mount two devices, boom, boom,
Gotcha.
as opposed to, I've said wall before, but I take that back. Ceiling mount. It's a lot easier to see. So that's what I would do. I would also provide, in this area, the computer room, I'd lay out a couple of Hornstroms in there that again are for evacuation purposes, because you have IT guys that are in there all the time. And if you get a general building fire alarm, they need to know the building is on fire. So, manufacturing, same thing. I think you would do fine as far as placing these devices, because you're at 21 feet, you're going to almost exceed the NFPA limit. So, Brian, how high can you install a strobe? And then what is its theory? You know, excellent about the finished floor.
Depends, doesn't it, on the canal and
It does. Okay. Anyway, what I would do in this room here is I would install the horn strobes on the perimeter. And go from there. Now, you've got a couple of bathrooms. In the bathrooms, I would simply go with strobe-only devices because they're such enclosed and confined spaces that if a horn went off in the bathroom, you'd probably lose your hearing. It would be too loud. And besides that, you'll have a horn strobe in the corridor right out here, and believe me, you'll get through that door enough sound pressure level that it's not going to be more than 15 feet that later the noise level inside the bathroom. Same holds true for that conference room down there for an office area. Put a strobe in there, not a horn strobe. So, enclosed offices do not require any notification appliances.
Mechanical
Any
rooms.
normally unoccupied area does not require notification appliances. But this mechanical room is pretty big, or generator electrical room. I'd probably put one at the exterior door and probably one at the interior entrance into the room. I'm not worried about ADA or coverage. I just want to get some. And any reviewing authority having jurisdiction, that's reviewing the design for permit, we build it, they'll have no issue with that. So, the fire alarm system, I guess we should talk about a little bit, just the basics of the fire alarm system. You've got a control panel, you've got detection devices, you've got notification devices. Pretty much talked about all the detection and notification devices at this point. The control panel itself, there's two basic technologies. One is known as conventional, the other is known as addressable. I don't believe anybody should be designing a conventional system anymore. The technology in our industry is essentially 100% addressable technology. And what does that mean? That means that sensor, this happens to be a heat detector, okay? That sensor has its own address in the fire alarm system. And is enunciated after control panel as heat detector in room whatever. It's got a chip in it, and it talks to the control panel, can interrogate that device, and depending on whose system you're selecting, what the technology is available, you can even potentially interrogate it to know what the temperature is inside the stove. Is a real-time analog signal. But we're not going to go to that extent. So, with that said, your devices again are connected to the fire alarm system via what's called a signaling line circuit. Also, your detection devices are. And a signaling line circuit, with the equipment that we represent, we can have up to 159 detectors on a single pair of wires. In addition to that, on that same pair of wires, 159 modules. Oh, what's a module? Well, I got to monitor flow switches and tamper switches, and I got to monitor that pre-action system panel. I got to monitor that valve assembly. I got to I gotta shut down air handling units, I gotta recall elevators. Okay, so modules provide inputs and outputs in the fire alarm system. So let's talk about first the inputs. And an input module is referred to as a monitor module. Monitor module is, again, going to give an address into the fire alarm system, a switch. That switch could be a flow switch, a tamper switch. It could be a relay on, the alarm relay on the pre-action panel. Any kind of contact closure can be sensed by the monitor module, and then in turn that becomes an input into the fire alarm system. So I don't know if your design needs to go to that level of detail to show it modules, but that would be your input side. The output side would be typically a relay module or control module. And again, we go back to the air handling unit where we have the smoke detector on it on the supply side. When that detector goes into alarm, we also have to shut that unit down. How are we going to do that? Well, we'll do a relay. So a relay module, once that detector turns in its alarm to the control panel says, okay, your software now, I got to tell that relay module to change state, and it does, and it opens the contactor that serves that supply fan and shuts it down.
Are you saying like clip with these and understand that for the really actual relays, or are you guys using like a PLCs or like where you're actually using like an internet software?
Well,
It'll automatically.
It's the module itself, the relay module is an intelligent device that sits on that signaling line circuit, that SLC. It's an 18-gauge two-conductor, cable. That's the device communication path with the fire alarm control. Draw a picture.
You can draw it here.
Oh, okay.
On the
I just use my finger.
no, here's tape. You see all the markers here? Let me
Yeah.
just give you a clean copy here. Give me a
Okay.
second here. I can do everything here.
I didn't think we were going to be here more than a half an hour.
Sorry. There you go.
Well, I don't know what's
You can go ahead.
okay. So here's your fire alarm control panel.
Oops. You have to put it back down and you just put them
What do I
down.
do? Put the pen down?
Yeah, and pick it up again. There's another one that's sitting kind of
This one?
crooked. There you go. You should be able to.
Oh, wow.
It's a little bit off.
Okay, it's off.
You
So let's draw our, here's our duct detector, sampling tube. Here's our relay module. I don't like that. It's not cooperating with me.
let me see if I can synchronize it a little bit for you. Can you click on that little button here? Yep. Right at the top, the X. Yep. And just keep following it. There you go. That will calibrate the board.
I got you.
Sorry, put you in this. Okay, hopefully that's better now. Let me just get you back into where you were.
Okay. So on this module, I've got a Form C contact. And I don't think we need to get into that much detail, but essentially what we're doing is you've got a normally, yeah, it's still not working. You've got a normally closed contact here. Okay. And that normally closed contact is pulling up the coil on a pilot relay.
Yeah.
All right? And that's holding that coil energized through normal duty. Okay? So what happens then is that when we get the alarm from the duct detector, the control panel then tells the module to change state. That opens this coil, which drops power to the pilot relay. Contact on the pilot relay is going to open also at that point in time. And the pilot relay is simply there to provide isolation from the low voltage fire alarm system to the high voltage air handling unit power. Okay? Make sense? So, yeah, relays are involved, but also logic is involved. You know, because the fire alarm, an addressable intelligent fire alarm system is software driven. You have to program it. You know, this device here has an address in the system. This device here has an address in the system. So when, you know, and then you write logic equations for all of the functionality.
Yeah. Yeah. I just wasn't sure if they were actually just using the logic itself, or if they were actually like tying it in with a relay, like an actual relay itself, not like a hardware. Right. You send out one relay, let it be controlled by that.
Well, it's a combination of the two, really. I mean, you know, the logic involved here is, and you mentioned PLC. Well, a fire alarm system is really a PLC. You know, it's a computer. It's inputs and outputs. PLCs do inputs and outputs, right? That's really what we're talking about here. This is the input. That's the output. The output in this case is to shut down that motor.
Yeah.
Okay. So
I'm not sure if they give I'm not sure if they typically give a normally closed dry contact in the control system of the air handling unit. And when you, if it's normally closed contact and you energize the coil that drive that contact, you just open that little contact, shuts down the air handling unit.
Yep.
Yeah. So you provide them with a dry contact normally closed.
exactly.
You
Well, we
energize it.
give them a Form C relay.
Yeah.
Form C contact, which is common, normally open on
Yep.
one side, normally closed on the
Yep.
other side.
And they'll take it
And
from
they'll
there.
take it from there.
They interface it with their control system.
Exactly.
Yeah.
However they want. If they want to normally close contact, they just tie onto that side. If they want to normally open it, tie on the other side.
Yep.
So, pretty simple stuff. But that's how that works. What am I missing? Talked about.
We mentioned a few things about the pull stations on the outside doors, requirement
yes.
for them.
Yes.
We said right now by code, but
They're not required by the code, even where fire alarm systems are required. In most occupancies, I won't say all, but in most building occupancies, manual pull stations are no longer required. Even in systems that are occupancies that are required for
Is that just because of the habit of people actually just
rate nuisance alarms.
temporary.
Now there's devices out there, you know, like what we call stoppers, pull station stoppers and other things like that. You know, it's a cover that goes, mounts over the pull station, and it's got a screamer built into it, so if you pull that thing off, you got 95 decibels just blaring ass, okay? It's a deterrent. Some people don't know that so if you pull it off, you get caught.
Especially if they're in daycare,
Exactly.
applications.
Manual pull stations, again, in the case of this system, would be a addressable device. So we call it a module, not a detector. Okay. Detectors relate to the word sensor. You're sensing smoke, you're sensing heat, you're sensing gas, whatever the case is. In the case of a manual pull station, that's more like a, basically we take one of our modules and we put it inside of a box that's got a handle on it. And when we pull that handle down, it closes the contact, turns in an alarm. Now, if they're required, in a building of this square footage, all you would do is put them at the hand side of the door, and takes it to the building. Not the inside, but the hand side, if at all possible. What else you need to know?
But we did paging system, we did fire alarm system, elevator manufacturer. There's hazardous location that we asked to run
okay.
intrinsic reserve system.
Okay,
We talked about the duct bank, so I don't know if we
well, let's
should
talk
focus
about
here.
hazardous materials,
Yeah.
quickly.
And then the rest is really, we're talking about ladder system, that's just for technology, so.
Yeah,
Here's the
that I
area,
can't help you with.
here's the area that we are.
Okay, so that's the hazard.
Plus one, div one.
You know,
Doors to doors.
let me ask you a question or two. I don't know what your criteria are. Here, you call it a hazardous material area. Is the room rated?
It's plus one, div one.
Class 1, Div 1, so explosion proof. So everything that goes inside that room has to be in rigid conduit, seal tight, with no potential for electrical arc. Right? What else was in the definition? I don't remember. But essentially, the only way you're going to be able there are explosion-proof fire alarm devices available. What I would do probably is put an explosion-proof smoke detector in the room. I don't believe it's any greater than 30 foot by 30 foot. And again, the explosion-proof smoke detector is listed for 900 square foot coverage. I typically would not put a notification device in there because it's normally not occupied. Right? If you, for whatever reason, needed to put one in there, again, you could use an explosion-proof horn and/or horn stroke. I don't know of any manufacturer actually that manufactures an explosion-proof combination horn and strobe device in one device. They have explosion-proof strobes, and they have explosion-proof horns. I don't know anybody that makes the combination horn and strobe device.
When you say explosion-proof, is that just based on the type of material, or does it also mean that like it's not going to be based on a lot of metal inside of it to create like a shrapnel issue or anything like that too, or?
Okay, no, what I'm saying is that device is built in such a way that it eliminates the potential for electrical arc. Okay? An explosive atmosphere, whether it be gas, fumes, or dust, which can be explosive with this granary fires and explosions that happen frequently out there in America. What we're talking about is eliminating the potential for electrical arc. So it's the device. Number one, all the wiring has to be in rigid conduit. That's got to be sealed. Threaded connections and sealed tight. The device itself, the smoke detector, that explosion-proof smoke detector, as you call it, has nothing to do with its ability to be able to withstand the explosion. And I apologize for the confusion. What it means is that it is constructed in such a way that there is no potential for electrical arc inside that device. In other words, the atmosphere that's in this room is explosive in nature. Therefore, the room is rated as a ANSI Class 1 Division 1 atmosphere. So we got to be careful about you've heard the story about the guy comes home from vacation and he forgot to shut the gas off on his range in his kitchen, right? And he came in the house and flipped on the light switch. Boom! Why did that happen? Because you had an explosive atmosphere and that switch caused electrical arc, which ignited the gas. So, explosion-proof devices manufactured in such a way that there's no protection. All the electronics or electrical components are sealed from this. It's very expensive.
And we're coming, because we have also lights there, and we have also
Yeah.
mechanical equipment that need to be powered. We have one chapter that talks about classification of various solar coming. To the lighting system have to be explosion-proof equipment, as well as your fuse disconnect next to that 16 and 15, these machines there need to be powered. So there's a lot of stuff that's coming.
I don't know if I did this in any logical order or whatever, but
And
what
I
else
think
do you
that's,
need to know?
I think that's basically it in terms of
Any questions?
any comments, especially guys, about the layout of the system. So we know how to lay out our paging system and our smoke detectors in different areas, horn strobes. The devil is in the details. I mean, there's a whole lot of other things that could happen in interface, but we're electrical designers, so the idea is we lay out the system. Ultimately, we'll be giving it to an expert like yourself who will add to it, delete from it, adjust it to make it work and pass the fire marshal approval.
And that's how that works.
Yeah.
You know, in the practical construction world, you know, a consulting engineering firm is going to design a system on paper with the construction documents. They're going to write a specification. It's going to dictate the performance of that system. Goes out on the street for bid. I bid the job. Typically, what I do is I'll provide a proposal to the electrical contractor. I'll become a subcontractor to the electrical contractor. I'm going to take care of all the fire alarm, paging, and hoisting data, whatever it is, low voltage systems that that electrical contractor wants me to perform for him. I get paid for that. We produce all of the shop drawings. You know, we actually take now that engineer's design and we put it on our catalog. And we fix any problems. You know, because most engineers know a little about a lot of things and not a lot about anything. So that's where we come into play, and that's why we're successful. It's because we cover people's asses. You know, so, and we do the spindles, we deliver equipment, we install it, we test it, maintain it. So it's all pretty good.
Any questions? Yes. Is this enough to get you up and running with your system? Laying out? So what we're doing is we're using Revit with families, all the stuff that you talked about, they're all coming at 3D families and we're throwing them in Revit.
Cool.
So that's can give people walk through the system and through the building. So, yeah. Well, thank you, I appreciate it.
Detective.